Hello everyone and welcome to your next chapter. The textbook does things in a slightly different order than I think I would if I was going to write this textbook. So we're going to take this week, do a bit of review of trigonometry before we jump into chapter 5, section 1. So if you remember trigonometry super well from before, feel free to just start jumping in and trying out the work from the worksheet. It's 2 pages, but they should go very quickly. Your presentation is number 2 in page 2, number 12. If you're feeling like, oh man, I could really use a big review on trigonometry, please keep watching the video. You feel free to pause and do all those things as you want. And if you aren't sure if you understand it, I encourage you to watch the video. But remember, the answers are attached to the worksheet in Google Classroom. So if you want to try, realize that you get the first couple wrong, come back, watch the video, nominate those problems in the forms attached. I will always go through and make explanations for those problems that I see nominations for. And I want to help you if you're stuck, but I won't be able to help you if you don't tell me. So let's get started, get yourself ready for notes, and we're going to review trigonometry. So trigonometry is a way to measure and analyze specifically right triangles. So I'm going to take, for example, the right triangle ABC right here. And there are 3 main what are called trig ratios or trigonometric ratios. And the mnemonic that you might remember is SOHCAHTOA. Seen this written on, I'm thinking, many a classroom board over the year. And if you remember, S stands for sine, which on your calculator is SIN. So sine of angle. So you'll often see theta here as the angle. And it's just the variable that we use for angles. If you remember, we use a lot of Greek letters, if you remember that from geometry. And that's equal to the opposite side over the hypotenuse. So these are always sides here. And then theta is always an angle. So we've got sine is opposite over hypotenuse. Cosine is adjacent, meaning the next to side over the hypotenuse. Or, tangent of theta, which is opposite over adjacent. And now the opposite and the adjacent side will change. The hypotenuse is always this long side opposite from the right angle. So in number 1, it just says find the following. What is the cosine of A? So if A is our angle, we're talking about this angle here. That means that 5 is the opposite because it goes straight across. And then 12 is the adjacent because it's next to. There's nothing in the way of it. So in this case, cosine of A is the adjacent side of A over the hypotenuse, which is always going to be the same for no matter what angle you're looking at. So the adjacent of A, we can see is 12, and the hypotenuse is 13. That's just the cosine of A. Now with B, I'm going to do a quick erase. With B, it's asked for the tangent of B. So if I'm looking at the angle B here, 5 is now the adjacent and 12 is the opposite. So that's the important thing here, is that as you change what angle you're considering, you're changing which side is the adjacent and which is the opposite. So this is the opposite of B, because we're considering angle B here, over the adjacent, because that's tangent, of B, which in this case, the opposite of B is 12, and the adjacent is 5. And we usually just leave things as a fraction. If you want to write it as a decimal, that's fine. Now for angle C, now we're looking at the right angle here. So C is here. It doesn't have an adjacent because weirdly enough, it has 2. And that means that we can't pick them because 5 is next to it, but so is 12. And if you pick different numbers, you'd end up with wildly different things. So there's no, if this is the right angle, that means that there is no adjacent. So we say that the adjacent is equal to 0. However, there is an opposite. In this case, the opposite of C over the hypotenuse happens to be the same thing. So we've got 13 over 13, which equals 1. And actually, the sine of 90 degrees, no matter what the triangle is, will always equal 1, because then the hypotenuse and the opposite are always going to be the same. Now, why do we care about trig? Well, we need to find the measure of angle A. If we're looking at this picture, we can use one of our trig ratios. Since it's saying angle A, I'm going to use the one from part A. So it said cosine of A is equal to 12 over 13. This is what we found out before. Now, we can use our calculator, and you are going to need your calculator for this. So what you're going to do is you're going to use the inverse function key on your calculator. So for most of you, you're going to have a button that says cosine. And then the second function will be cosine inverse, just like the inverse functions we've been reviewing. They cancel out. So when you take cosine inverse, the cosine and cosine inverse cancel out. So then A is equal to cosine inverse of 12 over 13 is what you'll enter into your calculator. And if you look at this picture here, it makes total sense that the answer should be about 22.6 degrees. Now, some of you are going to get a really weird answer that's going to be way too small. You're like looking at that and you're like, that's not a 1 degree angle. Now, this is where you want to check your calculator. You want to check the mode button. So click on the mode button, and what you're going to see is you'll have a bunch of different options on your screen. You're going to want to make sure to look for one that says radians or rad, and then DEG or degrees. These are just different units, and we'll talk about radians tomorrow. Just as a nice review, it's just about what unit you're measuring your angles in, and in this case, you're going to probably be measuring in degrees. So if you get a weird answer for cosine inverse for this problem, it's because your calculator is probably in radian mode, or maybe even one of the other units. The other thing we can use trigonometry for is to find missing side lengths. So we can find missing angles, we can find missing side lengths. Here we have another triangle ABC where we're given one of the angles. So you have to know one of them. Find the missing side lengths. So here we have our angle B, and I want to find B, which in this case is the opposite of B, and C, which is the hypotenuse. Now, to find each of these, because we know the opposite here, in order to find side B, this is the adjacent, I apologize. In order to find side B, if that's my goal, well, B is the opposite and we know the adjacent. So to find B, I'm going to use the tangent of B is equal to opposite over adjacent 8. So I'm just plugging in those numbers that were given. Now, B in this case is known, so instead of that, I'm going to say 25 degrees. Now, this is why it's important to have your calculator in the right mode, because tangent of 25 degrees is a constant. You can just type this in, as long as you're in degrees, so the units match, and this will give you a decimal. In this case, 0.906. It says round to the nearest hundredth, so I'm just adding in another decimal place to be safe. Sorry, that's the cosine of 25. The tangent is 0.466, which is B over 8. Now I want to get B by itself, so I multiply both sides by 8. On my calculator, I might just even use 8 times the answer using the second function of the negative button, so then I don't need to round at all. And that tells me that B is equal to 3.73. That's the nearest hundredth. And since the unit here is meters, B is 3.73 meters. Ooh, I'm just all over the place today. So there we go for B. To find C, C is the hypotenuse. So I still know the adjacent. It's still easier to use 8 than to type in that long decimal. So I'm going to use cosine of B, which is 25 degrees, is equal to 8 over C. Now, again, I can just type cosine of 25 degrees into my calculator, and I get 0.906, which is equal to 8 over C. Now, because C is in the denominator, I would just multiply that up, and then I would then divide by 0.906. So then C is equal to 8 divided by the cosine of 25. This might be how I type it in so that I don't have to worry about rounding at all. And that tells me that C is equal to 8.827, which means that I'm going to round up to 3, again, meters. So hopefully this didn't feel completely brand new to anyone. If this does feel completely new, please get in touch as soon as possible, because I am assuming that you've seen some trigonometry before in your geometry classes and maybe even before then. If you're stuck on anything, please nominate it in the form, reach out to me by email, Zoom, or in the class comments.